forces right now? Yeah, so any fire or EMS, or actually most police officers and everyone these days are trained on Narcan, for sure. If they're not trained on anything else, they're trained on Narcan, which is what they use when someone's overdosing. So all of them know how to administer shots. It's pretty easy. You stab and, like, depress the plunger. So, excuse me, get out yesterday's notes. Obviously, yesterday is being used in a kind of loose manner. We ended our last class stumped. And if you don't remember what we were stumped by, shame on you, because you should always continue to be curious on whatever stumped you. Yeah, the inscribed quadrilateral thing. What about what? The coins? Actually, Mr. Flynn solved it. So, if anyone has a proposition for a solution, you can propose it to me. But let's talk about that at the end of class, because my brain is distracted in too many ways right now, and I've already got a headache, so let's not push that any worse. So, we stopped class with, like, this stuff copied down and color-coded. It did not seem all that helpful. Like, I mean, we were following the advice of Dr. Smith, right? Do something, shade something, draw something, like, do something. So I started to think maybe we did too much. Right? Did anyone else feel like 4 colors there was just a little bit too much to keep track of? So, because I'd already color-coded this 8 ways from Sunday, 4 ways from Sunday, I guess. That's an expression, by the way. Again, if you've never heard it, I'm not just crazy. It's an old-timey expression because there's only 7 days from Sunday. If I color code less, let's bump to the quadrilateral to the right. Right? If I color code less, I know that what I have colored as my yellow arc up here corresponds to the inscribed angle that I have color coded yellow. I want you to take a moment on your own. What can we do from here? Unless anyone figured this out between last class and now, and then you can just tell us what you figured out. Margaret? So to make life easy, let's just call the bit, because I drew this line, let's say the whole angle here is angle B, angle I, angle R, and angle D. So if we talk about the smaller ones, we can use 3-point notation, but if you just use single point, I'll assume you're talking about the big angles. Oh, 234. So wait, what is 360 minus 234? 126. And I know I already had a degree symbol there, but I'm going to write another one in my pen. So if this arc is 126, what's that mean about this angle? Anyone notice anything about these two angles? Which we mathematically call, you're right, I just want you to use the vocab word. They are supplementary. So, wait, let's see, will that continue? Is that a rule? Is that something that we can just apply? Well, if I do the same thing with that quadrilateral, but from the other angle that they gave us, and I draw this line across the middle. So guys, if you have not added lines across the middle, this might be the thing that you're missing, because we can split the circumference into just 2 arcs, right? One with an angle that we know and one with an angle that we didn't. And then we can do it the other way around, right? Turn and look at the other 2 arcs. So what we had done last week was just too confusing. It was too much at the same time. This is what we want to do. It was just too much at the same time. So now over here we recognize, this angle subtends my blue arc of 170. So then my pink arc will have how much of the circle left? What's 360 minus 170? 190. What? If you whisper, I cannot hear you. So then this angle B degrees. We can check if I have 117, 85, 63, and I know I have 2 copies of the notes, so I'm kind of cheating since I can split up my colors, and 95, they should all add up to 360, which we said has a fancy name, but it's kind of hard to say. Explementary, I think it was. Take a moment on your own. Solve the first one over here. Solve for angle B and solve for angle R. Now again, I have all 4 color codings on here because on your paper you only have it once. So what our given information tells us is with an angle of 74, our arc is 148. With an angle of 92, our arc is 184. Who's confused? So the new rule, essentially, that we're saying is opposite angles of an inscribed quadrilateral must be supplementary. We don't even have to use the arc measures. If we turn this into like a rule based off testing it over here, we can just say, okay, well, 92 and its opposite arc, its opposite angle, they split the circle in half, not perfectly in half, but one portion and the other portion make the entire thing. So pink angle and green angle, or pink arc and green arc, make the entire circle. So angle B needs to be 88. And angle R then needs to be 106. Any questions on our new rule that opposite angles of an inscribed? Yeah. Now that we know that this is a theorem, because I am telling you, we've tested it, mathematicians have made sure this works, and we could actually go back and write a proof of it, but we're doing less of that this year because I have half as much time with you guys. So no, you don't have to use the arcs, as long as you know the quadrilateral is inscribed. So every point is on the circle. We now can say we know that opposing angles are supplementary. Yep, we can now just say we know that as a rule. Now, adjacent angles, for what we can tell right now, don't seem to really have any relationship. So be careful. We're talking about opposing angles. The adjacent angles don't seem to really do anything. Sweet. Let's go look at today's notes. My hope would be that we get done with these and then you guys have a moment to practice on Khan Academy and at least get through the articles with me available to take questions. I just assigned stuff this morning, so unless you were off task in first block and somehow got it done already, which I don't know. I mean, some of you guys, if your teacher says do whatever, I know you might go find the math stuff because it emails you. It was like 6 new things. Gross. Well, you don't have a math test. At least there's that. Yeah, 8th graders are the worst attitudes of all attitudes. What? Oh, thank you. Yeah, he's a cutie. The newest Hudson on Earth over there. And if you pull that off and flip to the back, you can see my brother. He thinks his long hair looks good. I'll let you guys decide if you think it's true or not. So, a tangent line. I feel like over the past 9 years of my teaching, I've realized, like, oh crap, kids are way more curious than I realized. Tangent line, we are only going to talk about in one application right now. But off to the side here, it is worth noting that any curve can have a line that is tangent to the curve. If you really want the simplified, what the heck are we talking about? Any curve is really an infinite amount of straight lines. Now, really, and then I use the word infinite, which is a word we can't get to, right? There is no really infinite, like we can't get to infinite. But if I zoomed way in on my curve, I'm about to break my camera. I doubt it's going to come back to focus. I'm going to try to get it back to focus. Oh, come on. I tried this earlier and it sort of worked, but the light has changed in here. Literally, when a laser jet printer prints a curve, we'll try it over here because it's darker. When a laser jet printer, or like any roll printer, prints a curve, notice how you can see straight lines. And it's because a printer can't print curves. You guys, I can't put my finger in there because it's gonna, here, I can come up here. But see how there's a straight line and there's a corner, and a straight line and a corner, and a straight line and a corner, and a straight line. It's pixels. Yeah, it's pixelated. Right? So just like the movie Pixels, well, I don't know about just like the movie Pixels, because Adam Sandler just defeats Pac-Man. But when we pixelate something, we see that it's really just straight line. Well, straight. All of this is like in quotations, right? So the tangent line is the line that is perpendicular to that straight line. So it only exists at a very specific point because the line is actually a point. Come on. So, if we allowed a point on the circle, what we're calling point B, to be a piece of the curve, if we zoom in far enough, every piece of a curve, when we get far enough, is a straight line. Because there's like, think of a billion straight lines curved around to make a circle. It would look like a circle. Your eyes would not be able to tell that there are a billion straight lines. But if we like literally each of them just has a tiny bit different slope, we can make a curve out of straight lines. What we're saying about a tangent line is the tangent line is perpendicular to that point on that circle. So there are technically infinitely many tangent line options, right? Because any point that we look at on the circle can have a tangent line. So if you grab your ruler and want to add some examples here. Yeah. Yeah, they're at the door. Man, now I owe a student of mine Kit Kats. She bet me that someone wasn't going to see my note, like my little station there, even though I wrote it in bright red Sharpie. And she bet me a dozen cookies. And I said, well, I'm not going to make cookies. I'll buy you Kit Kats, I guess. Huh? You don't get them. It's, Miriam, actually. Because you know her sister and you know she likes Kit Kats or what? What? Does she just like have some gambling ring that I don't know about and I just got sucked into somehow? That's awesome. Final example. There we go. All right, so if we draw more tangent lines on here, notice that like it's really hard to see the exact point where the tangent line intersects with the circle, but the mathematical rule that goes with this is at that point, again, kind of like quote unquote, because it's very hard to it's very hard to see what we're talking about. There is a perpendicular relationship between that line and the radius. So at any tangent point is where the tangent line touches the circle. We are perpendicular to the radius. Now, if you're curious about the why, again, I wish we had time to go deep into these things this year. Maybe once we're all back together and I get you every day, maybe we'll start to do more of these proofs. But the reason this works is this is actually an optimization. What that means is if I draw a distance out to my tangent line, I can draw this line and hit my tangent line, but we know it will be longer than the radius, right? Because it's going to turn into a hypotenuse. Why this relationship happens is it is the optimum, like the shortest distance from the center of the circle to your tangent line. That's all it is. So if I draw this, it's even worse, right? I'm going the wrong direction if I'm working that tangent line. So closer, and once I get to 90 degrees, that is the smallest that distance is able to be. There's a really good video in Khan talking about it. I did not assign it, so I don't want to make you guys watch it, but if you're curious, go watch it. It's interesting. So in the first example problem here, there's really no thinking needed. We're just going to regurgitate that rule. If I tell you that AC is a tangent line, what we know is that this is a right angle. The other way that statement can go is if I tell you that that is a right angle, then we know AC is a tangent line. So the question that I should ask you here really, is AC a tangent line? Well, what's 32 plus 58? 90, so what's this third angle going to be? 90, so is AC a tangent line? Yes. So now, angles is the easy part of tangent lines. Lengths is the slightly harder part. So now I'm going to stop talking and give you guys a moment to look at this problem. See, how could we figure out the length of AO? That's about 42 minutes, right? AO, the length of it. Or is it only like a half hour? I know it's not as long as extensions. Sorry, I'm just making a bad joke. So, Aaron, how do we do this?
Well, it already tells us what the radius is, which is 5.
Okay, so, but they tell us that here.
Yep. And so between point AO and B is also a radius, so that's also 5.
Oh!
Add 8 to that, and then you get your answer.
This part of the hypotenuse is also 5. Oh yeah, because it's also a radius. Hey, I don't need your tude, because there are students who, that will be a hurdle of visually, they just get stuck in trying to recognize that, so that's why I'm teaching this like I am. We don't need your tude. Think about it. If this was hard for somebody in the class and you... I don't know. I'm assuming well, maybe I should probably stop, but I'm assuming that Alina is similar to 7th grade Alina and always wants to... So do this next one on your own. And I also want to know if anyone recognizes the special here. I will come to you. You can flip to the back if you want. You probably already have, though. Anyone recognize what the special is here? Alina? That wasn't you, right? That was Katie Ann. What? No, it wasn't. I don't even want to figure out if you're messing with me or not. I swear it sounded like Katie Ann, so I'm not... We're going to move on. I really don't like this whole masks thing because it just makes things super hard, but I mean, it's obviously the safest option right now. So all of these problems, just to make sure that you recognize, oh yeah, anytime we're using a tangent line and another line extending out to the tangent, we always can fill in the radii length. So this will then become 20, which we see is a 3, 4, 5 actually. Any questions on our front here? I know we went a little fast. I'm hoping to have time during class to practice. So I know we're moving quick. Ah, crap. Now we're back to quadrilaterals. So, wait, we had rules about this, I think. An exterior angle to your circle. I gave you these rules in our notes. Does that actually help us yet? All right, well, one thing we do know if we follow Dr. Smith is that's also 3. The length of AB. What does circum mean? What is circum? Around. What is scribed? So, what do we think? I'm like really struggling with, I want to tell you guys less things. I want you to derive them on your own. Take a second with both of these. I just want to give you guys a few minutes to play with these. If you get stumped on this one, move over to this one. I'm doing too much giving you information. I like that. Maybe worth it to flip back to the front and look at the little thing I gave you. Avi? Yeah, now I think Avi, you're like adding in a line here, looking at 3, 4, 5. But why? I agree, but like why? How? If they don't tell you that this is 90. So we need to go back here and figure out what is this telling us, right? What does that mean? Angle A is circumscribed. So what this is telling us is the razor tangents, right? So what this is telling us is it has been drawn, right, scribed into the circle So this ray, literally at point B, is the same line as the point at point B. If you imagine that a point is a line for a moment, right? Any point on a line is part of said line. This is where it gets super complicated, and I'm not ever going to say this is easy. But guys, we're saying that we're perpendicular to a point. That doesn't happen, right? We're perpendicular to a line. So there's a point B on the circle where BO is perpendicular to AB. So B is operating as 2 points, 2 lines, 2 things at the same time, which is fine, and they're perpendicular to each other. So when an angle is circumscribed, guys, flip back to the front. This is showing us what we need to know. Angle C is circumscribed. So, as we solve these problems, we're going to see, really, guys, what kind of shape is this? And actually, if we flip back to here, it's almost easier to talk about. What is this? The whole thing. The tangent lines, the radii. It's not a triangle, it's a quadrilateral. Oh my gosh, guys, for real? We don't remember what shape has two. Thank you. It's a kite. We've made a kite with 2 legs that are radii and 2 legs that are tangents or edges or whatever you want to say. It's a kite, guys. So this will also be 6, and this will also be 3. Now, where this messes with us, sorry, go ahead. They're going to create a kite, yes. Yep. So, 2 tangent lines from the same point will be congruent. Now, here's where it doesn't look like that makes sense. When we see it as like an example problem, neither of these lines are flat. Flat, right, with the horizontal. So when they give us practice problems that now have a line flat with the horizontal, it looks a little funky because like our brain plays tricks on us about one of these is going to be longer or shorter, and they're congruent. So when this is flat, it starts to be a little weird, but same rule applies. Yep, so our lines from that point are congruent. Not a trapezoid, right? Because for a trapezoid, the top and bottom have to be parallel. So down here, all sides of ABC are tangent to circle P. And over here, all sides of ABCD are tangent. Take a moment, fill in everything we don't know. Yeah, absolutely. I don't do anything fake. Especially not plants. I love plants. I've had that bamboo since I redid my kitchen because I bought it from IKEA. That succulent, the smallest guy over there, is from Phoenix's Earth Day celebration 2 years ago. So we couldn't do it this past spring because actually none of us were in school, I don't think. Huh? How is it still alive? Water and love and sunlight.
My mom can't keep plants alive except
Takes just a tiny bit of dedication. All right, so this would be 5, right? And this, what is B to whatever this point is? 14. How do we figure out that this is 14? Oh, this up here is 10. So please be careful. This does not split in half. We use the coordinating tangent lengths here up from point A. This is 10. So here I'll zoom in. This is 10, making the remainder 14, making B to whatever this unlabeled point is 14. So the rule that we're going back to is this rule from the front, that a point with lines tangent to the circle, these two tangent lines, these marks, are telling us that they are congruent. So if you want to come back here and like highlight this or whatever, these are going to be congruent lines. So what we know is if this is 10, then this is 10. Why did you think that was 10? So this is 5, correct. This is 5. This tangent line has nothing to do with this tangent line. They're actually like separate tangent lines. So now, to find this, we have to relate it to this. So try again over here. Let's try to avoid the mistakes. Try again over on this one. Same sort of skills, except now it's a quadrilateral. Blue is the one that we have to figure out how to get to. All right, well, look up if you need help. Both of my pink lines would be 4. Both of my blue lines would be 8 based off of that 12. Both of my green lines would be 4. Both of my orange lines would be 5. Are there any preguntas? No preguntas? Muy bien. All right, well, pull out your Chromebooks or whatever you want, and let's do some practice. So if you guys have questions, we can Zoom with you. Blue, I'm going to try to, as we can incorporate, or sorry, y'all are green. Blue gets a deficit of days now, right, as we move forward. So every Friday is going to be sort of like bonus for us as we move forward. But please realize we got to take a mastery at some point soon, so it's going to default to quarter 4, since now our grades are going to quarter 4. But there are a couple of you that need to catch up on practice from like last week, or just a little bit old. And there are a couple of you that have not started this week's practice, right? Which I had kind of made the request of try to get it done as soon as you can, so we know by Thursday if we're having any issues. So that radian and arc measure stuff, guys, I need you to try to get that done, so I know if you're struggling or if we're good to completely move on and stop talking about it. Cool. So if you're behind, please try to get that behind work done. If you're behind, please try to get that behind work done.